I'm running out of time today, and I wanted to get to these properties, so I'm skipping example 7 for now. Sum and difference properties of logarithms. Usually I call these the product and quotient properties. So this has to do with if you have two parts to your argument that are multiplied together, you can separate those with addition. And if you have parts of your argument, of your logarithm, that are dividing, you can separate any of those with subtraction. So that anything in the denominator would be a minus, just like as if it is like a negative exponent because it's a reciprocal. And anything in the numerator would be a plus because it would just be multiplying with what's already there. So the reason this works is if I have something like x squared times x cubed, I don't multiply the 2 and the 3 together, I add them together. So it's 2 plus 3, which results in x to the 5th. And remember how a logarithm is an exponent, and so logarithms act just like exponents, and the product rule is actually addition, and the quotient rule is actually subtraction. Kind of like if we had like x to the 4th divided by x to the 3rd, we can simplify that by saying x to the 4 minus 3, and simplify that to x to the 1st power, right? And that's because the quotient rule for exponentials is that we would just subtract the exponents, because this is the same thing as like having 4 x's on the top and 3 x's on the bottom, and 3 of those reduce, and we're just left with 1. So that's why we subtract it. And same idea here, we have 2 times 3 of those, and altogether we have 5 x's multiplied together. Okay, so these properties we're going to use anytime we see the word expand our logarithms or write as single logarithms. Expand the following using the properties of logarithms, right? Exponents as coefficients and simplify. So that statement right there is telling us to use the power property, which is where we move exponents to the front as products instead. Assume that all variables represent positive real numbers. So in our first example here, we've got like 10 and x, and then there's a square on the x. So that's like 2 separate things that are multiplying together as products. So I'm going to separate those products as addition of logarithms instead. So log of 0.1 of 10, and I'm going to add that to log of 0.1 of x squared. So I've separated my 10x squared into a 10 times an x squared, which means with logarithms we add if they're multiplying. Now this one technically could be separated further if we really wanted to. We could separate our log 0.01 into 2, and we could separate it into a 5 so that we're like into prime numbers here, so that could be separated into that. That might be a little bit of an overkill. I'm actually going to show you something else that problem does that's really cool. But for this part, the last thing we've got to remember is that product property, not product property, but the power property, where the 2 goes in front. So we're going to keep the addition, but the 2, the x squared, is going to move in front of the log 0.1 of x. Now notice how the 2 is only in front of this logarithm and not in front of those logarithms, because those are not affected by the square. It's only the x that's affected by the square. So this is the only logarithm that has the 2 coefficient in front of the logarithm, because that was an x squared. Okay, I wanted to show you something else really fast though. If we have this part right here before I separated it into this and this, if I have log of 0.1 of 10, doesn't that mean I'm trying to figure out what power on 0.1 would give me 10? Well, remember, 0.1 is 1/10. So wouldn't it be 1/10 to the negative 1 power that's 10? So honestly, that first part of our problem can turn into just a plain old -1. We just simplified that using what we know about logarithms. So we have a -1 for the log 0.0110, and then we're just going to add on this logarithm that we don't know the value of because it has a variable in it. I'm just going to leave everything else the same. So this is 1 other way that we could simplify and expand out that logarithm. Okay, let's look at number 2. This entire logarithm has a cubed root. I think that's a cubed root, right? So immediately, hopefully, you would remember that a cubed root is the same thing as a 1/3 power. So I can rewrite this entire logarithm as 100x squared over yz to the 5th, that whole thing to the 1/3 power. That means that I can actually move that 1/3 to the front, and that could be a part of each piece in this. Alright, I don't like how I'm running out of room here, so I'm going to condense all of this just a little bit. Oops, I didn't grab everything. Nope. That's part of that. That's part of the problem. Alright, that's going to be harder to move than I thought it would be. Let's just grab all of this minus that and group all of this and squish it in. Alright, I should have paused my video while I did that. Forgive me. Alright, here we go. So this 1/3 is going to go in front of everything, right? So don't forget that as we separate out things, that 1/3 is still going to go along for the ride. Yz to the 5th. Okay, now let's separate out all of the little things. So we are going to have 1/3 the log of 100, because that's one of our factors. And then we can have 1/3 our log of x squared, because that's another part of our factor in the numerator. Now we're going to start subtracting. So minus 1/3 log of y, and then minus 1/3 log of z to the 5th. Now would this 1/3 be in front of everything if everything wasn't inside of that cubed root? No, it would not. Alright, now we need to simplify a few other things by moving these other exponents to the front. We're just going to multiply those with the 1/3 that's already there. So that will give us 1/3 log 100 plus 2/3 log x minus 1/3 log y, and then minus 5/3 log z. That could be considered done. We've expanded it. The only other thing I would consider thinking about at all is the fact that this is a log base 10 and this is 100. So log base 10 of 100 is the log base 10 of 10 to the 2nd power. And if you remember from our properties, that means that log base 10 of 10 turns into 1. And we're just left with that 2, which would move up front with our 1/3 and turn into a 2/3. So this whole problem could be simplified into 2/3 plus 2/3 log x minus 1/3 log y minus 5/3 log z. Everything has the third because everything was in the cubed root. The stuff in the numerator is positive, the stuff in the denominator, everything is negative. And here is our expanded and simplified logarithm. And I did do this little simplifying part where log base 10 of 10 turns into just 1. So that leaves us with a 2, and a 2 times the 1/3 is a 2/3.